Good morning, ma'am. Myself, G. Anusha from AIML department. My topic regarding AIT Tech Talk video is application of GIS network analysis in water pollution control of Huaihe River Basin. In this, Huaihe River Basin is a unique region in China with high densities in both population and water projects. And to control the water pollution in Huaihe River Basin, we apply GIS network analysis technology to water pollution tracing under water projects regulations. The study has put forward a water pollution management model as a GIS tool in the long term water projects regulating process and population control plan for the Huai River Basin. This is the GIS consists of two distinct disciplines, namely geography and information system. Geography is the scientific study of geospatial pattern and processes. It seeks to identify the location and account for the distribution of human and physical phenomena over the surface of the earth. Information system. Here information system contains electronic records. In this, input of source file, recording of electronic data, output of data. We give the data and that data is processed and we get the output of the data. Information system is also the combination of people, hardware and software communication device. What is GIS? GIS is the management of the information system that is used to input, store, retrieve, manipulate and analysis. First one, input, we give the data. Second one, store, we store the data. Retrieve, it is the search for the data. For the particular data we use retrieve. Manipulate means to modify the data or to change the data in the system. Analysis, after these four steps we analyze the data. And this is for planning and management of land use, natural resources, environment, transportations, urban facilities, administrative records. Application of GIS. These five are the applications of the GIS: facilities management, street network, environmental and natural resource management, planning, engineering and land information system. GIS has been readily used in water resource studies related to resource and environmental management. There are several reasons for this. First, analyses are too complex to be implemented within this network. Second one, a particular software is required for regulating reasons. Third, the software already exists and it would be insufficient to reinvent the wheel within a GIS. For the capabilities that the GIS environmental provides for problem solution are not well understood. In study of Huai River Basin, where the landscape is flat and water behavior is largely controlled by water regulating, the GIS network analyses are capable to have an obvious potential to model and stimulate the characteristics of drainage. Seventh, in the seventh slide we see about the Huai River Basin. Huai River Basin is located in eastern China between the Yangtze River Basin and the Yellow River Basin. It flows through the five provinces of China, namely Hubei, Henan, Anhui, Shandong and Jiangsu. It is the seventh largest river basin in the China, having the drainage area over 27,000 kilometers per square. The population living in the basin is 165 million. Its average population density is approximately 5 times the nation's average. Huai River Basin and is located in eastern China between the Yangtze River Basin and the Yellow River Basin. It flows through five provinces of China, namely Hubei, Henan, Anhui, Shandong and Jiangsu. It is the seventh largest river basin in China and having the drainage area of 270,000 kilometers per square. The population living in the basin is 165 million. Its average population density is approximately 5 times the nation's average. Although the annual mean precipitation and water resource of the basin are 3 millimeter and 83.5 billion respectively, water resources per capita and per unit area is less than one fifth of the national average. Moreover, more than 50% of the water resources are overexploited and is much higher than the recommended rate for international islands, 30%. In this figure, we can see that Huaihe River Basin is located between these five river river basins, and it is flows through the five provinces of China, namely Hubei, Henan, Anhui, Shandong, and Jiangsu. Huai River Basin is one of the top seven major river basins and has first established a rather vigorous plan of water pollution control in China. Huai River Basin is complicated network system including streams and water projects as being a semi-artificial network which is controlled by dam and floodage planning, management, maintenance, and emergency responses. These are the stream network requirements. Two series of provisional analysis tools which are closely related to the spatial modality and spatial distribution. From this perspective, GIS provide necessary technical support for the semi-artificial seam and network management. A network model can be defined as a line graph which is composed of links representing linear channels of flow and the nodes are connections. For the drainage network model, a planar network is assumed, that is, lines intersect only at a node. For the stream network model established for the study, the network elements include links, nodes, and also the centers are defined. Links are the channels of flows and they are connected to each other at nodes are the basic elements of a network. Nodes are endpoints of links and they represents the drain intersections. Example, the location of a reservoir or dam through which water flows into a river or another drain. The Huai River Basin Network Model as established in the network model system, there are totally two level links means channels, 213 nodes that are intersections, and 61 centers which are water projects such as reservoirs or dams. This is the figure of geometry network model. It is also the comparing to the hydrographic map data. There will be two major accomplishments for this network model. First of all, stream elements will be properly connected topologically into network structure. All stream segments within one drainage basin will be linked as a tree. Tributaries drainage basin will be branches of mainstream drainage tree. Second, water flow direction of each stream element will be the building is an attribution property of the elements. It is especially significant for any dynamic simulation regarding water flowing in the river network. Based on these two characters, it is always possible to determine the water flow along the rivers. As links are allocated to the center, demand of each allocated link is accumulated until the center's resource capacity is reached. If the demand of an arc would be exceed this capacity, the link will not be allocated to the center. Capacity measures the total amount of flow that can be supplied to or taken from a center to meet demands along links and nodes. The resource capacity of the center is the maximum amount of resource that can be supplied to or from the center. As the links are allocated to the center, their demand is accumulated, and if the total demand exceeds the center's capacity, the link node will be accumulated to the center. In stream network, all stream flow towards the catchment outlet. The arc info gist stores a network as a combination of links and nodes, which means futures, line futures, and point futures. The futures consists of their geographical coordinates and key to their attributes, which are stored in tables managed by a relational database management, that is RDBMS. Detailed results of network analysis are stored in GIS as additional attributes of the network database. Therefore, for the hydrological analysis, the GIS are used as a pre and post processes by linking its databases to the complex numerical application supported by external program. Based on the two important properties of the flow network database, it always can stimulate water flowing along the rivers. At each point at streams, we can determine from where all water flow come to the point, and it is possible to simulate potential pollution resources when a monitoring station detected problem. It is also predict and expected that Hawaii River Network database will it is expected that Hawaii Network will benefit environmental protection program by providing powerful simulation database for Huaihe River Basin. Application: a drainage basin for water pollution has two simulating tasks. First type of task needs tracing up capability and along the river network. Figure writing: the hydrographic network provides the tracing up capability from any location to a river drainage basin. It is another type of work involves emergency cases. In case of much pollution, materials have been dumped into a river at a known location and drainage basin. Conclusion: a task oriented approach was adopted to an integrated GIS and water resource application within a GIS network. Tasks are required to create and process the network model where GIS data processing routines and external programs. ARC and info network analysis routines were used for constructing the stream network model with ARC macro language AML and C programming language as the main development tools for hydrologic modeling. More complex time variant simulation computation procedures are not well suited. GIS databases are static, and GIS native programming languages are not geared toward numerical analysis, thus precluding easy incorporation of complex numerical. For time varying analysis, the GIS can be used as a pre post processor by trying its databases with complex numerical applications. Thank you.